Hi everyone, Mr. Markwick here. In today's video, I'm going to show you how to calculate the area of a triangle using trigonometry. Now, for the sake of this video, I'm not going to show you how this formula is derived or the proof of it. I'm just going to show you how to apply the formula once you have labeled your triangle correctly. So generally, to work out the area of a triangle, we would use the formula area equals half times base times height when we're given a perpendicular height, which is at right angles to the base, and a base length. And we just substitute those values into the formula to work out that area. However, if we don't have that information, we may be able to use trigonometry. However, you do need some values. You need two side lengths of a triangle and the included angle. So they're the measurements you need. Two side lengths and the angle in between those two sides. If you have that, you can use trigonometry to work out the area. First thing you need to do though is to label your triangle and start with the vertices. So start labeling those points or those angles with a capital A, a capital B, and a capital C. And directly opposite those capital A, B, and C values, you will label the side lengths with a lowercase a lowercase b, and a lowercase c. Now, depending on the two side lengths that you have and the included angle will determine which variation of the formula you will use. Now, generally the formula is given here, area equals half times A times B times sine C. But we can also use different variations of that same formula as shown there. So if, for example, I had lengths A and B and angle C given, I would use that first formula. If I had lengths B and C and angle A given, I would use the second formula. If I had lengths A and C and angle B given, I would use that last formula. And it really depends how you label that triangle. So this doesn't necessarily have to be an A up here. A could be down here. But depending on the two side values that you have and that included angle will depend on which one of those three variations of that formula you will use. Hopefully that makes sense. Let's look at an example I have down here. I'll have a triangle with two side lengths given, 8.4 centimeters and 11.7 centimeters, and the included angle, which is 31 degrees. So let's go ahead and label the vertices or the angles there. So let's start here with A, B, and C. Capitals, opposite those vertices or those angles are our lowercase. So down here would be lowercase a, across here would be lowercase b, and finally length lowercase c over here. Now, I have length b and length a given to me, and I know angle c. So I'm going to use this variation here, which has lengths A, B, and angle C in it. All I then do is write that formula down. The area of this triangle is equal to half times length A times length B times sine C. Substitute the values that I have from this triangle into this formula. So then it becomes half times, instead of A, I'm using 11.7. Instead of B, I'm using 8.4, and instead of the capital C, I'm using my angle value there, which is 31 degrees. Then I can go ahead and put that into my calculator. Now, just quickly, if you are using a graphics calculator like I am here, once you head into your run function, make sure it's set to degrees or you won't get the correct answer. By default, these are set to radians. So to change that from radians to degrees, we go Shift, Menu, so that activates the setup. We can scroll down there and change from radians to degrees, exit, and then we're just putting in this formula here. So half times 11.7 times 8.4 times sine 31. And that will give us the area, which to one decimal point, let's go to that, 25.3 centimeters squared, okay? Now, that's pretty much it. I just want to point out that, again, this is not the only way to label this right angle triangle. If I wanted to, I could have decided that this was C, this was A, and this was B. That would, of course, then change the side lengths to lowercase b here, lowercase a here, and lowercase c here, which would mean, oh, it's getting messy now, which would mean I would use a different variation of this formula. So instead of half times a times b times sine c, I would use half times a times c times sine b. Okay, hopefully that makes sense. Again, I know it's not much of an explanation, but it's about labeling that triangle correctly, and then based on that, choosing the correct, I guess, variation of that formula, substituting values in, and it's as simple as putting it in the calculator to work out the area. So yeah, hopefully that helps, and thanks for watching.